did someone tell you that the chapter of electricity is extremely important for you? Not just for class 10th here, even for class 12th. Believe me, क्लास 12th में ऑलमोस्ट पूरी फिजिक्स में आपको इलेक्ट्रिसिटी मिल जाएगा कहीं ना कहीं किसी ना किसी शेप में. सो इफ इलेक्ट्रिसिटी इज अ जर्नी, द फर्स्ट स्टेप in this journey is Ohm's law. And today that's why we are here in this short session we call as the Concept Bites. Welcome everybody, I'm Saurabh, your physics mentor, and today I'll be taking you through the journey or the first step towards electricity, that is Ohm's law. Ohm's law बहुत important है, बहुत ज़रूरी है. क्यों? In the chapter of electricity बहुत सारे formulas हैं, right? There are a lot of formulas in the chapter of electricity, but almost all the formulas they'll be using this one particular nice cute little law, the Ohm's law. So why not learn it entirely, starting से लेके end तक completely, right? Are you with me? Yes, everybody. Let's start. Now, Ohm's law is a law which is lot of times done in practicals, right? इसको हर बच्चा कहीं ना कहीं क्लास 10th में करता है practicals में, and you might have also done it. अगर अभी तक नहीं किया है तो आप करोगे पक्का. क्लास 10th में very famous practical is of Ohm's law. Now, we can't do practical right now, but you know what? We can do something the way we do it in style. How? Using a simulation. So let's see. Let me show you this nice simulation of Ohm's law. And this is exactly what you will be doing in this practical of Ohm's law. I'll tell you now. ध्यान से देखो. भाई, what do we have? First of all, notice this circuit diagram. Look at this. The circuit diagram is, we have a battery over there, right? Then what do we have? After that we have a resistance, right? There is a resistance. Across this resistance there is a voltmeter to measure the voltage across the resistance, right? Then there is an ammeter to measure the current across the resistor, है ना? Resistor से कितना current flow कर रहा है, not across basically. I would say how much current is flowing through the resistor, and resistor is in series. तो यानी कि circuit से और resistor से current same flow करेगा, right? So that ammeter is measuring the current flowing through the resistor, all right? Then what do we have? The key or the switch, all right? So this is the circuit diagram, all right? Now look at this circuit. By circuit diagram you have seen, but now look at the circuit, exactly the same. This is one cell over there, then there is a resistor, across resistor there is a voltmeter, then there is an ammeter, then there is a key. ठीक है? अब करना क्या होता है इसमें? In this, we have to first of all turn the switch on and take readings of voltmeter and ammeter. क्या measure कर रहे हो आप? You are measuring the voltage across the resistor and you are measuring the current flowing through the resistor. ठीक है? क्या क्या? Voltage और current की measurement कर रहे हैं हम लोग. बहुत बढ़िया. चलो, let me turn the switch on. ठीक है? Notice, the moment I turn the switch on, what do you see? Voltmeter is reading 1.5 volts and ammeter is reading 75 milliamps, है ना? Voltmeter is reading 1.5 volts and ammeter is reading 75 milliamperes. All right, ठीक है? Now we have to plot a graph. Graph कैसा है? ध्यान से देखो. The graph looks like this. The y-axis is the voltage reading. The x-axis is the current reading. Okay, fine. You have chosen the proper scales. बहुत बढ़िया. And then you have to mark that point. Point कैसे mark करोगे? Sir, voltmeter का 1.5, ammeter का 75 milliamperes, दोनों जहां मीट करेंगे, that will be my first point. So when you mark the VI point, you will get something like this, and I have joined them both with a line. ठीक है? All right. Now if I increase the number of cells, if I make 2, notice the voltmeter and the ammeter readings. Voltmeter reading is 3. It was 1.5. अब कितना हो गया? 3. Ammeter reading is 150 milliamperes. How much it was? 75 milliamperes. Mark one more point. एक और point लगा दो. All right, we have got one more point. All right, now just join all these points. It's looking like a straight line ना. ठीक है, एक और try करते हैं. If I add one more cell, हर cell add करने पे how much is the change in voltage, or let's say increase in voltage? It is 1.5 volts. 4.5 volts is the reading now. ठीक है? मार्क कर दिया पॉइंट वहां पे. देन द एमीटर रीडिंग इज 225. कितना इंक्रीज हुआ? 75 milliamperes, राइट? Mark कर दिया point again, and then when you mark this point again, you are getting a straight line, and the same thing you will get with one more cell. So this is what we do in this practical of Ohm's law. We have to obtain this graph, and this graph is supposed to be a straight line. अगर आपने कोई गलती नहीं करी है तो, राइट? सो दिस इज व्हाट वी डू इन ओम्स लॉ. अब इससे हमने सीखा क्या, राइट? दिस इज ऑल द ऑब्जर्वेशन वी हैव मेड. नाउ लेट्स डिराइव, और आई वोंट से डिराइव, लेट्स हाइपोथेसाइज दिस लॉ, है ना? ऑब्जर्वेशन हो गया, अब बताते हैं हमने क्या देखा और इसका लॉ क्या बन सकता है, राइट? सो लेट्स सी. Let's say again, I'll show you a table. This is the kind of table you obtain. Not the exact readings, but this is one more type of reading you can say. वोल्टमीटर का 0 है तो एमीटर 0 है. वोल्टमीटर 2 वोल्ट था, एमीटर 1 एम्पियर था. वोल्टमीटर 4 वोल्ट था, एमीटर 2 एम्पियर था. वोल्टमीटर 6 वोल्ट था तो एमीटर रीडिंग 3 एम्पियर थी. ठीक है, हमने वोल्टेज और करंट रीडिंग मेजर कर ली. फाइन. नाउ वी हैव गॉट द ग्राफ ऑल्सो. भाई 2 पे व्हेन इट इज एट 2, current is at 1, when it is at 4, current is at 2, when it is at 6, current is at 3. So we have got a straight line. This is the graph we have obtained. Now, what do you think? How can you give me some statement regarding Ohm's law? As much as voltage is increasing, current भी उसी proportion में बढ़ रहा. हमेशा current कितना बढ़ता था? 75, 75, 75, 75 with every addition of one cell. वोल्टेज कितना बढ़ता था? 1.5. सो हर 1.5 वोल्ट इंक्रीज होने पे करंट इंक्रीज होता था 75. देयर इज अ वे इन विच यू कैन से दिस. वोल्टेज is proportional to current, as simple as that, you know. So that's how we obtain this graph, I mean with the practical. But how do you understand it? Voltage across this resistor is directly proportional to the current. अगर वोल्टेज बढ़ेगा तो करंट बढ़ेगा, वोल्टेज कम होगा तो करंट कम होगा. ठीक है, that's very simple. This is the graph you obtain. लेकिन इस स्टेटमेंट में मोस्ट ऑफ द पीपल, आई मीन इवन गुड स्टूडेंट्स, दे फॉरगेट वन वेरी इंपॉर्टेंट थिंग. टेम्परेचर नीड्स टू बी कांस्टेंट. इफ यू फॉरगेट दिस, देयर इज अ प्रॉब्लम. यू विल लूज मार्क्स. नाउ लिसन टू मी. yes, voltage is going to be proportional to the current, but when if you maintain the temperature constant, अगर आप टेम्परेचर को ही चेंज कर दोगे तो रेजिस्टर की वैल्यू ही चेंज हो जाएगी. वी शुड नॉट डू दैट, राइट? यू कैन नॉट चेंज द टेम्परेचर. इफ यू चेंज द टेम्परेचर, द वैल्यू ऑफ रेजिस्टर विल चेंज ऑटोमेटिकली, राइट? सो वी हैव टू से एट कांस्टेंट टेम्परेचर V is proportional to I. Now, whenever there is a proportionality and you have to convert it to equality, you have to add a constant, है ना? तो हमने क्या किया? We added R. This R is called as the resistance, right? इसका यूनिट है ओम. लॉ कौन सा है? The law is Ohm's law, right? Ohm's law. The unit is ohm. This is, by the way, not that ohm which you are thinking right now. This is omega, right? This is a Greek letter omega. This is how we represent the ohms, all right? So, V is equal to IR. Can I say V upon I is equal to R? What is V upon I? It is the slope. The slope of this particular graph is the resistance. And if it's a straight line, the slope will remain same, right? Very good. So, Ohm's law is at constant temperature, the current passing through a conductor is proportional to the potential difference applied across it. Simple. Starting करनी है at constant temperature से. Now, this is what we have said the Ohm's law is. ठीक है, temperature रहेगा constant और V is equal to IR. This is how normally we all remember Ohm's law. Ohm's law क्या है? V equals IR. Everybody, टपाक से आंसर आएगा. V equals IR. ठीक है. Now, listen. For ohmic conductors, this is what the graph looks like, right? The VI graph is a straight line. For a straight line, the slope remains constant, है ना? If you take the slope of this much portion, or this complete portion, the slope will remain same. Now it's a straight line. So this is what we call as a ohmic conductor. मतलब the conductors which follow Ohm's law, right? Or the materials which follow Ohm's law, in which voltage increases proportionally with the current, right? If this graph does not come to be a straight line, यानी कि ऐसा आ जाए, ऐसा आ जाए, ऐसा आ जाए, ठीक है? If it is not a straight line, उसका एक नाम होगा. We call it non-ohmic conductor. Means they do not follow Ohm's law. ठीक है? That is called as non-ohmic conductors. So Ohm's law की definition हो गई, right? What is ohmic conductors which follow Ohm's law? What are non-ohmic conductors which do not follow Ohm's law, right? अब सुनो ध्यान से. V equals IR and R equals V upon I, which I told you, है ना? ठीक है. अब इसमें ना एक चीज और है ध्यान से दिखने वाली. भाई ये देखो, V equals I into R. If resistance is less, current is going to be more. मतलब सर, भाई if V is equal to IR and I maintain a constant voltage, है ना, जस्ट बी विद मी. इफ आई मेंटेन अ कांस्टेंट वोल्टेज दैट इज V, इसका मतलब IR that is the product of current and resistance needs to be constant. Why? Because voltage is constant. भाई LHS constant है तो RHS भी तो constant होना पड़ेगा, right? This is constant, it should be constant, right? Correct. So I multiplied by R should be a constant. If R is less, I needs to be more. If R is more, I needs to be less, right? अगर resistance कम होगा, ज़्यादा current flow करेगा. If resistance is small, more current will flow through the circuit. Means the bulb will shine brighter. ज़्यादा current मतलब ज़्यादा brightness आएगी, ठीक है. Next, if I say resistance is more, अगर resistance ज़्यादा होगा, then you have to think current will be less, right? If current is less, means the bulb will shine dimmer, है ना, हल्का हल्का जलेगा. Alright, so this is the second important thing. You should understand, resistance ज़्यादा होगा, current कम होगा. Resistance कम होगा तो current ज़्यादा होगा, ठीक है. Alright, now second thing, if you have two different types of graph, that is VI graph, and you have to compare their resistances, आप कैसे करोगे सर? स्लोप से, राइट, है ना. यू अंडरस्टैंड दैट वी हैव टू फाइंड द स्लोप, ठीक है. सो व्हाट इज द स्लोप? सर स्लोप इज चेंज इन वोल्टेज डेल्टा V अपॉन चेंज इन करंट डेल्टा I, राइट. सो R1 इज इक्वल टू डेल्टा V अपॉन डेल्टा I. सेम थिंग here also, this is delta V2, let's say this is delta I2. So R2 कितना आ गया सर? डेल्टा V2 अपॉन डेल्टा I2, ठीक है. अब किसका स्लोप ज्यादा है भाई? इफ आई लेट्स से आई कीप दिस डेल्टा I एज कांस्टेंट, ये बड़ा है कि ये बड़ा है? V2 बड़ा है ना, राइट. द स्लोप ऑफ दिस पर्टिकुलर ग्राफ इज मोर, so we say R2 is more than R1, and there is a very simple formula. I mean, फॉर्मूला तो सिंपल है. इफ आई गिव यू वन मोर इंट्यूशन, स्लोप को देखोगे ना, व्हाट इज स्लोप? इफ यू सिट ऑन दिस इंक्लाइन प्लेन, दिस लुक्स लाइक इंक्लाइन प्लेन ना, है ना. अगर आप इस पे बैठोगे, लेट्स से यू सिट ओवर हियर, ऐसे आप यहां बैठे, ठीक, एंड इफ यू स्टार्ट स्लिपिंग, यू विल स्लिप स्लोली. इफ यू सिट ऑन दिस पर्टिकुलर इंक्लाइन प्लेन, अगर आप यहां बैठ जाओ, देन यू विल स्लिप जुप करके, राइट. सो दिस इज how this particular thing works. आप किसमें कितनी स्पीड से स्लिप करते हो, that has more slope. ज़्यादा स्लोप होगा, you will slip faster. If the slope is less, you will slip slower. As simple as that, right? So R2 का स्लोप ज़्यादा है R1 से, बहुत बढ़िया. If you want to visualize resistance, resistance क्या है? It's an obstruction to the current. What is current? Flow of charges. So resistance is the opposition offered by the atoms of the current carrying conductor to the flow of electrons. जब इलेक्ट्रॉन फ्लो करते हैं, that is what constitutes the current, है ना. अब इलेक्ट्रॉन्स जब फ्लो करते हैं, रास्ते में क्या मिलता है? व्हाट डू दे फाइंड इन द वे? दे फाइंड द एटम्स. एटम्स आर देयर, देयर इलेक्ट्रॉन्स आर फ्री मूविंग हियर एंड देयर, है ना. इलेक्ट्रॉन्स इधर उधर फ्लो कर जाते हैं, करेक्ट. अब दे इनको बोलते हैं, वी कॉल देम द फ्री इलेक्ट्रॉन्स. बट व्हेन दीज इलेक्ट्रॉन्स स्टार्ट फ्लोइंग इन वन डायरेक्शन, दे स्टार्ट टू गेट टैकल्ड बाय दीज ह्यूज एटम्स सिटिंग इन बिटवीन, राइट. अब यही obstruction is what we call as the resistance. So resistance happens because of collision of electrons with positive ions, due to which the wire offers resistance. Positive ions क्यों बोला भाई? If something is sodium, right, it will look like this, है ना. This is the nucleus. फर्स्ट शेल में कितना होगा सर? 2 इलेक्ट्रॉन. सेकंड में कितना होगा सर? 8 इलेक्ट्रॉन. लास्ट में कितना होगा सर? 1 इलेक्ट्रॉन, है ना. एटॉमिक नंबर 11 होता है ना इसका, राइट, करेक्ट. सो दिस 1 इलेक्ट्रॉन विल कीप मूविंग हियर एंड देयर, राइट. अब whenever an atom loses an electron, उस पे अगर इलेक्ट्रॉन नहीं है, हम क्या बोलते हैं? What do we say? If this last electron is taken out, the sodium will become Na plus, right? इसीलिए हम बोल रहे हैं sodium ions. Correct? Fine? Alright. So, collision of electrons with positive ions, due to which the wire offers resistance. R equals V upon I, and now we understand. Alright, चलो ठीक है. We have learned enough. Let's solve the question so that we get confidence कि हमने सच में सीख लिया है ना. मजाक नहीं किया कर रहे हैं हम लोग, हमने सीख लिया है. कैसे? प्रैक्टिस करते हैं. John ran an experiment and recorded 1.5 amperes and 100 volts on an ammeter and a voltmeter respectively. Find the bulb's resistance. देखो, this question is easy. If you know the answer, pause the video, solve the question, and then rewatch it. Just cross check, okay? Listen. Find the bulb's resistance by what is R? Sir, R equals delta V upon delta I. So, he recorded voltage reading as 100 volts, current reading as 1.5 amperes. So 100 volts upon 1.5 amperes. Solve करना ना. This will become 1000 by 15, 5, 3, 5, 200, कितना आएगा? 66.67 ohms. So option D is the correct answer. As simple as that. V upon I करना है, कुछ नहीं है. Let's see a case study question. Your favorite. Sherlin conducted an experiment to verify Ohm's law, as we did in the beginning. She plotted a VI graph for a resistor and obtained a straight line later on. She repeated the same experiment with other resistors of different resistances. She obtained different kinds of graph. Will different graphs be also straight line for ohmic conductors? Read the last line again with me. Later on, she repeated the same experiment with other resistors of different resistances. She obtained different kinds of graph. Will different graphs be also straight line for ohmic conductors? Ohmic conductors are the conductors which follow Ohm's law. For them, VI graph is going to be a straight line. Yes! All the graphs for ohmic conductors she will obtain, they will be of straight line. Slope अलग हो सकता है, बिल्कुल हो सकता है. Slope से क्या मतलब है? Slope is resistance, right? But the graph should be a straight line. Fine. चलो. Let's see the first question. The VI graph of the three resistors R1, R2 and R3 is shown below. Which of the following relations holds true? Which relation holds true? अब ध्यान से करना देखो इसको. You have to compare basically the slope of these graphs, है ना? If you know the answer, pause the video, right, and solve it. If you don't know, keep watching. So no, R1, R2, R3. You have to compare the slopes of these three different lines. If we go by the layman method, क्या था? किस पे बैठ के सबसे स्पीड से फिसलोगे? On which inclined plane if you sit, you will slip quickly? R3, right? R3 has the maximum slope, so we can say R3 has the maximum resistance. That is the layman terms. Second term could be कि भाई, if I draw a line like this, right? इसका मतलब delta I is constant for first graph also, second and third, यानी कि R1, R2, R3, three lines जो है ना, for these three lines delta I is constant. Now this is what? This is V1, this is V2 and this is V3. Now you tell me, R3 is equal to V3 by delta I, R2 is equal to V2 by delta I, and R1 is equal to V1 upon delta I. सबसे बड़ा कौन है भाई? Denominator is same, right? Denominator is same in all of them. Numerator को we should compare. Now you tell me, V3 is more or V1 is more? V3 is more, na? Right? This V3 is more than V2 and V2 is more than V1, right? So सबसे बड़ा V3 यानी कि सबसे बड़ा R3. So R3 is maximum, then there is R2 and then there is R1, right? So you can say option B looks correct, na? So option B is the correct answer. I have given you two methods. First is the layman one, second one is the proper method of comparing the slopes, right? Higher the slope, higher the resistance. Okay, chalo. Next question, one more question. Let's see. The potential difference across an electric toaster when it draws a current of 4 amperes is 60 volts, alright? How much more current is drawn by the toaster if the potential difference is increased to 75 volts? Calculate its resistance. This is slightly half a level up from the last question. If you know the answer, I mean, if you understand, if you think you can solve the question, pause it and solve it. केवल देखो मत, solve करो, ठीक है? Otherwise, you keep watching and people who are solving right now, you cross check it once you are done, है ना? चलो देखो. Potential difference across electric toaster, ठीक है? Current कितना है भाई? The current I is 4 amperes, I1, and V1 is equal to 60 volts. ठीक है? How much more current is drawn by the toaster if the potential difference increases 75 volts? ठीक है? Now potential difference is increased. कितना current और draw करेंगे? Do you remember in our experiment, the first one, if voltage was increasing by 1.5 volt, current was increasing by 75 milliamperes, है ना? यहाँ पर कुछ वैसा ही question है. So for that, it's better to find that constant. Constant क्या था? Sir, V upon I was constant, right? If you find that constant, you can find any one of the values के बाद तो है ना? So R will be how much? Sir, V1 upon I1 यानी कि 60 upon 4, that is 15 ohms. हाँ, this 15 ohms will remain constant until unless you change the temperature. तो resistance find कर लिया. अब वोल्टेज दिया हुआ है और करंट फाइंड करना है. हाउ डिफिकल्ट इज दैट? थिंक अबाउट इट भाई. वोल्टेज इज V2 is equal to 75 volts. I2 is equal to, I don't know, but resistance is 15 ohms. तो यानी कि 15, or I would, let me write the formula. R is equal to V2 upon I2 is equal to 75 upon I2. 15 is equal to 75 upon I2. I2 is equal to 75 by 15. 5 ampere is the correct answer. Is it? No. Why is 5 ampere not the correct answer? Question क्या है? Read it. How much more current is drawn? कितना करंट और ड्रॉ होगा? पहले कितना हो रहा था? I1 was 4 amperes. I2 is 5 amperes. So more current means I2 minus I1. That is 5 minus 4. That is 1 amperes. Extra current कितना draw हुआ? 1 ampere. That is the question, right? So 1 ampere is the correct answer. And resistance 15 ohms. So 1 amperes and 15 ohms is the correct answer, right? Feeling confident? This is the beginning of electricity. Today, if you understood everything, means you'll do good in electricity. Don't worry, we'll keep meeting again. But before that, I have to give you a small homework. This homework is important. I want to see all the answers in the comment section. Go ahead, try it out because इससे you will learn a lot of things. बहुत common question है ये, बहुत तरीके से आता है. Again, you might have seen a similar question, लेकिन ध्यान से करना है इसको. Again, I have given you a VI graph and I have given you the R1, R2, R3. You have to arrange the resistance R1, R2 and R3 in the decreasing order. Decreasing order में लगाना है and give me a one-liner explanation of why you chose that answer. आपका आंसर जो आया वो क्यों आया? इसके लिए एक लाइन में मेरे को स्टेटमेंट बता दो. I want to see you have really solved it. Okay. So all right, this is the homework for you. I want to see all the answers in the comment section. With this, I would say keep learning. We'll meet again. If you like this video, press the like button right now. It's important. And share this with your friends. Small concept bite session for you. This is according to our plan. And you subscribe to the channel अगर आप कोई भी नए हो. If you are new, subscribe the channel and press the bell icon so that you don't miss any of the video. Extremely important. All right, everybody. See you next time. Take care. Bye-bye.